I'm here, Emma. I'll try.
All right, we'll just give it a couple more seconds while people are logging in, and then we'll get started.
Hi, folks. Matthew Lanigan here with BayWa RE. I'm the head of sales here for BayWa Canada. Really appreciate you taking some time to be with us and our great partner Enphase and to learn more about their products. Just a couple of housekeeping notes before we do get going. This will be recorded. It'll be put up on our YouTube channel later today, so you can find this recording as well as all of our previous recordings. It'll also come out in our newsletter, which should come out probably Monday next week. Continuing education is one of the core pillars of BayWa, so we're happy to extend that to our customer base as well and really appreciate it. And if I could just have somebody test the questions box, make sure that's working well, and then we can get going. Great, thank you. So without further ado, we have our friend Chad here with Enphase Energy. Chad?
How's it going? Can everybody hear me all right?
We can hear you.
Let me get my screen sharing, and hopefully you should be able to see my screen now.
We can.
Perfect, thank you. Appreciate the warm welcome and the opportunity to come in and talk to everyone and train you all on the IQ8 commercial installation and design. So I hope everybody is excited and ready to learn. We do have a lot of content to cover, so we're going to jump right in and get started. So if you're familiar with our residential offering that Enphase has, you've installed the residential systems before, the new commercial microinverter system architecture is going to be very, very familiar to you. It is very similar, and it is comprised of the same components, essentially. So you can kind of see the overall items here, starting with the Enphase IQ8 commercial microinverter, then the Enphase QD cable. That then takes the power over to a sub-panel board where each circuit will land on a 20 amp 3-pole breaker. Then it'll be combined in that panel and then sent over to the utility panel for your point of interconnection. For site intelligence, the microinverters communicate with the commercial gateway located at the PV subpanel or near the PV subpanel. The inverters and gateway communicate via power line communications. The gateway gathers a lot of details about the PV system. It will monitor DC volts, DC amps, AC voltage, AC output amps, AC grid frequency, and inverter temperature. You'll use the Enphase installer app to talk to the gateway, commission the site, configure and enable meters, and pull some post-install docs. And then we have the Enphase installer portal, which is accessed via the web portal or app, and it shows contractors, installers, or owners granular details of the site. It also makes it very easy to manage every aspect of that system, from monitoring to troubleshooting, and is very easy to understand how your system is performing. So as you can see just off that quick little snippet, if you are familiar with the residential systems that Enphase offers, it is very, very similar. So we're gonna start taking a deeper dive into the components. And first we have the microinverters, then we have the cabling and accessories. And just like the residential side, we have a specific QD cable that collects the AC output from each microinverter. We have connection ceiling caps for unused connectors, center tap adapter cables, and EN4 to MC4 adapters. The commercial gateway includes production CTs, and if you want, you can add consumption CTs to measure the site's energy usage. You can also add the mobile cell connection. And if you're planning to mount your microinverter to a module frame, we have an optional frame mount bracket. And then you'll also need a standard 3-phase subpanel, which will be sourced locally for your particular project, depending on the size and number of circuits coming into that particular panel board. Let's move into some of these inverter details. So the IQ8P 3P commercial microinverter has the following specs, as the power output rating is 480 volt amps. Now that can be confusing because you might hear 480 and think 480 volts. This operates on a 208 volt. The output is 480. Our engineers did not do us any favors when they're building this particular product with the 480, a little bit of confusion there, but it's 480 volt amps, and that is the output. Most people would just say 480, but since they are intelligent and reactive power sources that respond to site conditions, the technical way to represent that is volt amps. Like I mentioned, it operates on a AC output of 208 volts. It has that 3-phase sensing built in. It has a wide operating temperature range. So no matter where you are, extremely cold, extremely hot, this thing will still produce and it'll work as it's intended. The single MPPT, so that means it's one panel per one microinverter architecture. With that, you get that per panel monitoring, so you can really diagnose and understand the entire system from that granular level from each microinverter, each panel. It is 97% CE efficiency. It meets the compliance standards for utilities, AHJs, and has rapid shutdown built right in without requiring any additional hardware. As soon as this microinverter senses that there is a loss of utility power, it'll shut down the entire system. And lastly, they are IEEE 1547 and UL 1741 and 3741 compliant. To mount the IQ8P 3P, there's a couple different ways that you can do it. First, the microinverter, all the microinverters come with the bracket already pre-attached to the microinverter. So you can mount it to the rail as you see right here, or you can rotate it. So those connectors are a different orientation depending on how your panel is going to be sitting and where your connectors are on your module. It gives you a little bit of flexibility to be able to rotate that microinverter on your rail. You can also mount it, like I mentioned, to the module frame. In order to do that though, you will need to purchase the additional frame mount bracket to be able to mount the microinverter to any module frame. Let's jump into the QD cable and we'll start going over any of the all the accessories that are required for the system. But before we do that, I'm just going to pause and see if anybody has any specific questions about the IQ8 microinverter.
I'm not seeing any questions at the moment.
All right, sounds good. We will continue on. The QD cable is the 4-wire 3-phase AC bus that collects all the microinverter output and sends it to your sub-panel board. If you're familiar with the residential, this is essentially the same cable as the Q cable that the residential microinverters connect to. Obviously, the only difference is this is that 4-wire cable. It has phase rotation built in, so you don't have to worry about that as much. It takes a lot of the guesswork out of it and not really having to understand what phase rotation is as much. Like I mentioned, has the 12 AWG conductors inside of the cable. Each circuit will get connected to a 20 amp 3-pole breaker inside of that sub-panel board. And there are 12 IQ8P 3P microinverters per each circuit. There are 3 different sizes or lengths of the QD cable, and that's all dependent on connector spacing. The first one is meant for portrait, so modules that are going to be installed in portrait. The connector spacing is 5.6 feet from each connector. And those come in 120 connectors per box. The next one is for landscape orientation. Each connector spacing is 7.9 feet, and that also comes with 120 per box. The last one is for larger modules that will be installed in landscape. And these have connectors that are 9.5 feet apart. Now that one is a little bit different because only 108 connectors will come in each box. And this is so that the connectors that will have to plug into the microinverter will be close to center of each module that you install. That's why there's this specific spacing in between each connector. Voltage rise can be a concern. So Enphase recommends that you keep your voltage rise at less than 2%. So all of the QD cabling options come with center tap connectors already built into the QD cable. So like on the previous slide, I mentioned that there are 120 connectors on a length of QD cable. After every 6th connector that is meant to have a microinverter plugged into it, there is a center tap connector already built into that cable. So that center tap connector is required to be used on any circuit that's larger or longer than 6 microinverters. And this will reduce that issue of voltage rise. You're going to wire center tap connectors to center tap adapters cables and then run those home runs over to your sub panel. If you were to take a length of 12 microinverters and you pull power off one end of that QD cable and do not use the center tap connector, you'll have the voltage rise will become quite high, which in turn will shut off several of those microinverters. So you'll be losing production and the system will not be imbalanced for the system to be working properly. Now, this is a very important part, and we're going to continue talking a little bit more about this as we go on, but I do want to pause right there to make sure that everybody understands that and see if there are any questions, and just kind of reiterate that center tapping the QD cable, it is required, but it is very simple. All the parts and pieces are there. There's no really guessing or extra design work that you have to do with that. It's just a part of the installation process.
Any questions around that, folks? Okay, I'm not seeing anything, Chad, so far so good.
Cool. So placement of the center tap plug does matter. Like I mentioned, after every 6th connector, there is a center tap plug on the QD cable. So here's an example of a simple 12 microinverters in a circuit. And we started with the very first connector in the QD cable box. Well, that means right in the middle of that circuit, you're going to have a center tap connector in between the 6th and 7th microinverter. That's where you would plug in your center tap adapter and run your home run back over to that sub panel board. But what happens if you didn't start with the very first connector out of the box, or you don't have the perfect number of 12 microinverters in each circuit, and you kind of vary all over the place? Well, to reduce just waste, you can start with whatever connector is next in the series. Well, that means at some point you might have 2 center tap connectors in your circuit. All you need to do is identify which center tap connector has the most microinverters on either side. And that's the one that you're going to use to pull your home runs back to your sub panel board. So this example, you can see we have 2 center tap connectors. We're going to use the one that's on the left side because it gives us the most microinverters on both sides. And again, this is all to help reduce and eliminate voltage rise concerns. If we are starting from drop 3, and the center tap plugs will be between 4 and 5 and 10 and 11, again, we'd use the one on the left because it's closer to the middle of that circuit and it has the most microinverters on either side. And that is a common misconception, and a point that a lot of people don't really understand is when you hear the term center tap, you think it has to be in the center. Well, it has to be as close to the center as possible. So as long as you're picking the center tap that has the most microinverters on either side, it will work as it should. So the following accessories are intended to be used in conjunction with the QD cable and Enphase commercial microinverters. So we talked about the QD cable. Now we have male and female wireable connectors, and those are for making up jumpers and home runs. We have QD terminators, which are for insulating and waterproofing the cut ends of the QD cable. So we would have those at each end of each circuit. The QD disconnect tool, which can help you disconnect male and female wireable connectors, microinverters from the QD cable, different things like that. We have QD sealing caps for waterproofing any plugs on the QD cable that you may have skipped for whatever reason. We have raw QD cable, So that's just a 4-wire cable that doesn't have any connectors on it that you can use to make jumpers between arrays or home runs that you would use and install the male or female wireable connectors onto that raw QD cable. We have center tap adapters, which is what you would plug into the center tap connector on the QD cable. And then we have EN4 to MC4 adapter cables. They will go from the EN4 bulkhead on the microinverter to your connector on the module. We have wire management clips for the QD cable. And then we have some different PV cables and adapters if needed, depending on the type of module you're installing and the size of the module. Let's talk about the EN4 to MC4 connectors. So each microinverter on the IQ8 series, on the IQ8 commercial series rather, has EN4 connectors on it. Enphase provides EN4 to MC4 connectors with each commercial microinverter. So this is not an extra piece that you're required to purchase. This comes in every single box of microinverters. It is important to understand that there's one side that has to be plugged into the microinverter and one side that will be plugged into your solar module if your solar module has MC4 connectors on it. So each EN4 to MC4 adapter is clearly labeled with which side needs to be plugged into the inverter and which side needs to be plugged into the PV module. Like I mentioned, that EN4 to MC4 adapter comes with each microinverter. So inside the box of 12 microinverters, there are 24 EN4 to MC4 adapters that are included. Those adapters are 5.9 inches long. And if you need ones, or you're installing a module that does not have MC4 connectors on it, we have other options where you can get the EN4 that's 5.9 inches long that does not have a connector on the other side. So you can install whatever connector that you might need to plug into your solar module. Or if you need a longer EN4 to MC4, we have that as well. And if you want just a blank EN4 that's long to be able to go from your module to the microinverter because of it, how that module is landing or getting installed, we have those as well. Those three though will have to be ordered for your particular project. Like I said, the only one that comes with it is that 5.9 inch long EN4 to MC4 adapter. The center tap adapter cable, like I mentioned, is very important to reduce that voltage rise, and it is required to be used on any circuit that has more than 6 IQ8P 3P microinverters. On one side, it has a 4-pole link connector, which will plug directly into that center tap connector on the QD cable. The other side has a female field wireable connector. So all you would have to do is make up a male field wireable connector on some raw QD cable, plug it right into that connection, and then you can take that power over to your sub panel board or a junction box to then transition over to whatever wire and conduit that you might need. I'm going to pause right there for any questions.
Any questions, folks? I don't see anything, so I think we're good for now, Chad.
Awesome. The IQ Gateway Commercial 2 is specific to the IQ commercial microinverter. They look very similar to other gateways, so it is important that you are ordering the correct material and making sure you're taking the correct material out to site to install. The microinverter needs to be powered by a 3-phase 208 volt, typically by a 15 amp breaker. We like it to be installed as close as possible to all the microinverters. So you can see it has a 246 foot of conductor length that it's sending that power line communications through. So the closer it is to all the microinverters, the better that communication will work. It includes 3 revenue grade production CTs that are rated for 400 amps. When they are being installed, the arrow must point toward the load and away from the solar array. If you want to monitor and measure the entire site's loads, we do have optional consumption CTs that are rated for 600 amps. And if you have sites that are larger than 600 amps or other issues that require a different monitoring, we have different meters that we use to send information from the point of connection to our gateway. We have Wi-Fi and Ethernet options included. And like I mentioned earlier, we also have that mobile connect cellular kit as an option if you need it. When outdoors, the gateway must be installed in an enclosure rated NEMA 3R. When wiring the commercial gateway, you're only going to be using 2 terminal blocks on the gateway. The one on the left is to power the block, and you'll wire 3 phases and a neutral into it. The block on the right is to power the terminals, is for the CT wiring. The 3 production CTs will wire into the first 3 ports. From left to right, you'll start with line 1 to line 3. The consumption CTs will wire into the 3 ports to the right of the production CTs, line 1 to line 3. The consumption CTs are not required for your site. The only thing that is required are the production CTs. Let's get into some design considerations for the system and design constraints. Because the Enphase commercial microinverters use reactive power, its output power is measured in volt amps. The max output power is 480 volt amps for the IQ8P 3P microinverter. The max continuous output power is 475 respectively. The nominal voltage range is 208 with a max output current of 2.28. The maximum number of microinverters per branch circuit is 12. Having that maximum number 12 makes it easier for designing, because all you have to do is take the total number of panels on your project and divide by 12. That's how many circuits you're going to have. Now, if your project doesn't have a perfect multiple of 12, then you're going to want to have as many circuits that are fully loaded with 12, and then try to keep the other circuits in multiples of 3, 6, 9. That way we get better phase balancing across each circuit. The Enphase commercial product that we currently offer does only support native 208 volt 3-phase Y systems. With a transformer, you can support other 3-phase voltages though. So if you're not working with a 208 volt three-phase Y system, you'll have to introduce a transformer in order to use this particular product. The three components that will influence your system design the most is the microinverter, the QD cable, and the gateway. So the gateway uses those power line communications to communicate with each microinverter. It is capable with communicating with up to 275 microinverters with a maximum footage connector or conductor length of 240 feet. So here's kind of an example of what that might look like. We have a system with 275 commercial microinverters. That's 23 branch circuits of the IQ8P 3P microinverter. And we have one commercial gateway. That commercial gateway is going to be installed near our sub panel board load center, and that's going to be monitoring all of those panels, all of those microinverters. And then that sub panel is going to be taking all of that home run power, combining it right there, and sending it over to the point of interconnection. If you're designing a project larger than that, it's not an issue. We can still design and build projects larger than 275 commercial microinverters. We just have to add a line filter. So with power line communications at the micros being at and directly through the AC circuits, if you're building a larger site with multiple gateways, you'll need to add line filters to prevent interference or crosstalk over the separate domains. So essentially all you need to do is every additional gateway, you'll need to add a line filter for each one. So here's another example where you can see a basic diagram.
We do have a couple of questions here. Where would the transformer be installed in the circuit to be compatible with non-WYE system? Any estimate on cost for a small transformer?
I don't know a cost on a small transformer. That would be up to, the particular design for that system, and that would be, you could install that transformer after that sub panel board. So then it would get it would go through the sub panel board, be combined, and then you would use that transformer to bring that that power to whatever it needed to be at the point of interconnection. But price and the type of transformer would have to be figured out for that particular. It's very project specific.
Great, thank you.
So it's just kind of like with the multiple gateways, you just add that extra line filter per each additional gateway. So you can really scale up your system size as large as you want, as large as you need. There are limitations, just like with any system, but adding those line filters will help you be able to get to the size that you need. And also, even if you have one commercial gateway, or you have less than 276 microinverters, you still might have to install a line filter if you're on a building that has a lot of line noise coming from machines, medical equipment, different things like that. So it's always something to keep in the back of your mind when you're looking at or designing projects, is what is inside of that building, what is using that power inside of that building, so you understand if a line filter might be needed for that clean communication. Now, if you're thinking like, wow, that's a lot of stuff to remember. How am I going to know what parts and pieces I need to order and get? You know, there's accessories, there's line filters, there's this and that. I totally get it. So once your design is complete, or even if you just want to kind of fool around with a size project, we have a system builder tool that would create a custom bill of materials for your project. So you can go on our website, go to our system builder, fill out some specifics that only ask you these 4 questions, and then calculate it, and it'll spit out a custom bill of materials for your project that includes Enphase products as well as third-party products. And you can export this into an Excel file, and it's great and easy for sharing. So it takes a lot of the stress away from, hey, what do I need? Do I need to order the center tap adapter, or did that guy from Enphase say it came in each box? Oh no, that was the EN4 adapters. So this takes that guesswork out of that and makes it very simple for you to use. I'm going to pause right there before we jump into kind of phase rotation inside the QD cable.
And we do have another question. Is the system builder for both commercial and residential projects?
Yes, the system builder is for both residential and commercial. I'm going to go back 1 slide. So right in project type here up at the top, that will drop down and you can choose residential or commercial.
Thank you.
Obviously, if you choose residential, these questions are going to look a little different. Good questions. Any other questions out there?
I think that's it for the moment.
Okay, let's talk about how phase rotation works inside of the QD cable. So the QD cable is where all the magic happens when it comes to microinverters putting power on the correct phase. So the microinverters produce at single phase 208 volt, and the QD cable alternates that 208 current over 3 lines. So every third connector on the QD cable puts power on to line 1. The second one puts power onto line 2. Third one, line 3. There's 4 pins in the microinverter. The first 2 pins are power pins, and the second 2 pins are sensing pins. So you can see in this diagram, the first microinverter that's plugged into the first connector on the QD cable, the pin 1 will put power onto line 1 and line 2, and sensing on 3 and 4. The second one will put power onto line 2 and line 3, and sense on 1 and 4. The third one will put power onto line 3 and line 1, and sense power on line 2 and 4. And so on down the line. That's how you get the ideal phase balancing and phase rotation from those microinverters. So like I said, the QD cable is where all the magic happens because it does all of that phase balancing for the system. It's built into that QD cable, and that's why it's so important, such an important component to the entire system.
We have another question here. Is center tap also considered best practice for residential installations, or is it less important for residential?
So on the residential systems, I would say it's not required. However, I've installed a lot of residential Enphase systems in my solar career, and I would always install center tap connections on my residential systems because it does help with reducing the risk of voltage rise. So not required, recommended. With the commercial side, it is required.
Thank you.
So we're going to take another look at a kind of a larger scale, and you can kind of see this is an example system that has 5 circuits on it. And this is extremely important to understand when you're cutting the QD cable. So on the first circuit, it goes from 1 to 9. Well, since it stopped at 9, we need to start the first connector in the next circuit with the 10th connector. That'll help keep phases balanced. If we skip connectors and we went from 9, let's say we skipped 2 connectors, we just cut them out of there because we wanted to start back at 3. Now we're potentially putting more power onto certain phases. So it's extremely important to make sure that when you're cutting the QD cable, as soon as you cut the QD cable at whatever length of circuit that you need, the very next circuit starts with the first connector that you didn't cut. So here's an example of a center tap connector. So you can see we have microinverters, center tap connector, and then microinverters. Each center tap connector on the QD cable says, do not plug microinverter into it. It says it, it's got a red sticker on it. However, a microinverter can still plug into that center tap connector on the QD cable. If that happens, you'll wind up with one extra inverter connected to lines 1 and 2, which would look like this. So now you have another example of what not to do when putting power, because you're having additional microinverter putting power onto line 1 and line 2, which is going to throw off the phase balancing for that particular circuit. So very important to not utilize the center tap connectors for anything other than connecting a center tap adapter to. Any other questions?
Not seeing any at the moment.
Okay, move on to system commissioning. We have a little video. I don't know if we're going to watch all of this, but if you've installed a residential system, you're going to use the same installer toolkit app to commission a commercial system. It's going to ask you the same questions, and it's going to walk you through the same steps of how to commission the system. It has the CT wizard built into the app. So like I said, I'm going to fast forward this a little bit because it is a little lengthy of a video, and we're kind of getting a little closer to the end of the time, and I just kind of want to leave some time at the end for any additional questions that anybody does have.
Any questions out there, folks? Great time while we have our friends with Enphase here with us. I'm not seeing anything at the moment. Chad?
All right. Well, we'll just kind of let this play and see if anybody comes up with any. So if you haven't used the Installer Toolkit app before, it walks you through all of the steps, and it won't let you go to the next step until the previous step is completed and is correct. So there's no chance that you can set up or commission the system incorrectly. And if you get an error or a message that you're not sure what to do, the app will walk you through troubleshooting. Like I mentioned, it has the CT wizard built right in. So if you're having issues with CTs, maybe you didn't install them correctly, it'll give you troubleshooting techniques to figure out what the issue is. So this video was probably, takes about 15 minutes to commission a system on average, and it's this video was condensed to like 5 minutes, but it is a relatively quick process, and you can get all your information right from the app. You can pull reports on the entire system that you can share with the customer, and it's really easy and friendly to use. So some resources we mentioned, I covered a lot of different stuff. Your minds might be, just blown with all of the information that we covered, but there's a lot of helpful links and resources at Enphase. We have a dedicated course that you can become a certified installer and designer with a commercial products. We have a custom commercial landing page on our website and a commercial business owner page that anybody can check out. We also have a dedicated commercial YouTube channel. So if you go onto YouTube, you can see tons of Enphase helpful installation videos and trainings that cover, everything on the residential side. But we have one specifically for the commercial side. That way it's a little bit easier to search and filter for the video that you're looking for. We have that system builder tool on our website, and then we have a bunch of other very helpful items that are all over our website. And if you do have any questions, feel free to reach out to the Enphase team at commercial sales at enphaseenergy.com, and we can help you answer anything that you need help with.
We do have a follow-up question here, Chad. Where did it disappear? Sorry, there's two here. For ground mount applications with more than 12 panels in a rack, what solution do you recommend for bringing the additional microinverters to the combiner panel? Just QD raw cable to junction boxes and then the combiner? And also
that's exactly what I would do.
Okay, great.
So yeah, if you have, that's a great question. You have, let's say you have a ground mount rack that, I don't know, maybe holds 24, holds 20, whatever it is. It doesn't even have to be 12 per circuit, right? You would just take however many are in each circuit and then go from the center tap connector to raw QD cable, take both of those raw QD cables over to a junction box, wherever you're going to be pulling power, whether it be in the center of that rack at either end, take it over there, and then you can just transition from that junction box and pull THHN to wherever you need to.
Great. And then we have another one here. What type of solution does Enphase have for commercial customers that want to publicly display energy production? For example, a company might want to display energy production on a TV in the lobby.
That is a great question, and we have it's called the kiosk view that is included in the services that that the actual owner of the system can utilize and put in, like you mentioned, on a computer screen, on a TV, that will show different aspects of the system, kind of whatever they want to set up. It's very customizable, and it's all included in the product.
Great. Any last questions out there, folks?
While they're thinking about typing it, there's one thing I didn't mention that is a very helpful resource. So if you already have an Enlighten account at Enphase, you can utilize the free commercial design review service. So you can go onto your Enlighten account, go to services, go to design review service, and if you have a commercial project that has been designed or you have questions about it, you can submit it into our commercial design review team, and they will review it for you for free and make sure that it is correct, it's accurate, and it's ready for permitting. That way it takes all the guesswork out, especially, if you're new to Enphase or new to, this product, this system, you want to make sure you get your first several designs correct. We will take care of that for you.
And we do have another question here. Is the gateway equipped with CAN bus or RJ45 port that we can send the solar system reading to a different energy monitoring platform?
So you can't use a different energy monitoring platform. You have to use the Enlighten Enphase monitoring. We do have paired with you can use any SunSpec Modbus meter to connect to the commercial gateway in order to be able to monitor a larger input power coming from the utility to this particular building, or if the point of interconnection is really far away from where the gateway needs to be installed. That way you don't have to run or extend CTs, you can just run an Ethernet. But when it comes to monitoring the system, you will have to use the Enphase Enlighten monitoring system.
Great. Well, I don't see any other questions. So thank you very much for everyone for attending. Thank you very much, Enphase and Chad, really great partner. Appreciate our relationship. Just a couple of things before we go. This once again was recorded, so it'll be on our YouTube channel. If you haven't signed up, please sign up for that. We would love it. If you haven't signed up for our web shop yet, please do so. It's a very powerful tool. We like to think of it as an extension of your procurement team. You can go in there, you can see all your pricing, availability, spec sheets, install manuals, warranty documents. It's all there. So it's a great resource. If you have follow-up questions, please don't hesitate to reach out to your inside or outside teams. They're well versed in Enphase. And once again, thank you everybody for joining us, and really appreciate it, and have a great rest of your day.
Thanks, everyone. I appreciate the opportunity.
Take care.